video, we're just going to have a look at a few things around uneven sampling periods and collapsing. So I'm going to begin by opening my workbook, and I'm just going to remove this collapsed data set here, which is the one I want to create, because I want to look at C even and C uneven. Now C even here is a data set of quarterly by quarterly data. However, all of the data actually comes in the first quarter of each year. So all the rest of the rows, the accident periods are zero. So in a way, it's redundant to have these extra accident periods here. In earlier versions of ICAFIS, when we weren't able to have arrays with uneven periods, this is the way that we treated, in this case, quarterly development. Development is quarterly, calendar is quarterly, but accident is annual. This is the way we treated uneven sampling periods. In order to do this, we also associated an exposure with each of these triangles, and the exposures are designed to ensure that when you run the forecast, you get zeros in the rows with the zero data in them. So what we have is in each first quarter of each year, the exposure is at the high number, and comparatively the exposure in the three accident periods for which we don't want to have forecasts are very low numbers. And so when we run the forecast, it's not going to average out the model to those zero rows. It's going to give you a zero forecasts in each of those rows. Now, with ever since ICAFIS 10.2, we've been able to use uneven sampling periods. So this is the same data, but now in a collapsed form, and the accident periods now are annual, but the development and calendar periods are quarterly. So this corresponds to the situation where your data is basically annual, however you have quarterly, or your bookkeeping is annual, as it were. You look at each accident year, each underwriting period is an entire year, but your data comes in and is revised every quarter. So the natural way to model this is using these annual by quarter triangles. So let's go back, and I want to see how to collapse the even triangle here in order to produce the same uneven triangle that we had before. Now if we look at the dimensions button here under the data set with the C even, we can see the pattern here. It's quarterly. It begins in the first quarter of 1986, ends in the third quarter of 2000. Now, as you may recall from the data is only recorded in the first quarter of each year. So what we'd like to do is to collapse this in such a way that the first quarter of each year becomes the key. So that's to show you what I mean. Let's look at this. Let's change the accident. This is the collapsing dialog box. Let's change the accident sampling period to annual. Now the default here is to fit the last calendar period of the triangle. If we were to take this, then the last calendar period, which was the third quarter of 2000, as you may recall, would be the reference point. And so the accident years would run from the fourth quarter of one year to the third quarter of the following year. However, since the data comes in the first quarter of each year, what we're going to do is align it to the first quarter. So now the accident years, we begin counting in the second quarter of each year, and we end in the first quarter of the following year. So, and we retain the calendar period as quarterly. So when we collapse here, we get this collapsed triangle group, and you'll see that the numbers in this paid loss array are exactly the same as the numbers in the one that we call C uneven. I think I have to do this manually, put these two side by side. And you can see that they're identical. We scroll down, they both end in the same way. Up in the top left corner, they also have exactly the same numbers and exactly the same number of development periods. Now, when I collapsed this, the exposures automatically were added together. So these numbers here, 1000, are actually 1000.000003, the very small exposures that were given for the accident years that didn't contribute anything. The accident quarters that didn't contribute anything actually get added into the exposure, but that doesn't show up here. So we just get 1000 for each. Now, actually, I'm going to close C uneven and just use the collapsed one that I've just created and compare this to the results I get with C even. So what I want to do is bring up that. So I have the two. There we are. So there's the even triangle, which is the quarterly by quarterly with the 0 quarters in the accident year. Here is the collapse, the uneven quarterly by annual by quarterly. And I've already got some wizard models here, but I'll delete these and create them again. So what I'm interested in seeing is how do these wizard models compare. But before we do the wizard models, let's just open the standard SGI models in both cases and put those side by side. And we see that in fact the two SGI models are identical, because PTF counts the 0 entries as, well, doesn't count them, basically, ignores them. And so the data that it's actually using to estimate the parameters are exactly the same data as in the even case. Now, because the calendar periods are not collapsed, the calendar trends remain the same. If I was to have collapsed the calendar periods, so I collapsed the triangle to annual, accident by semester, by half yearly calendar periods, then of course this trend of 0.316 would be doubled. It would be 0.6 something, 0.066%, because now each calendar period would represent 2 quarters instead of 1 quarter. Let's look at the residual displays here and place those side by side. And in fact, they look very similar. The difference is only in this. The difference here is only visible in these little buttons here at the bottom of the accident period display. And here we have little buttons for each quarter. But of course, where there's no data, we don't get any data points, but we have little buttons underneath those. So if I right-click one of these, well, nothing happens at all. Okay, now let's run the wizard model for both of these. So I can't run them both simultaneously because they're belong to different triangle groups. So let's start with this one and run the wizard. I'm just going to pause so you don't have to wait all the time it takes the wizard to do this. And that's that one. And now I'll do the same here. I'll run the... where's my wizard gone? There it is. I'm going to run the wizard on the even data, and again I'll just truncate your perception of it. So there it goes. And now the wizard here is just finishing. Good. Now if you look at the two accident period displays here, the results look identical for even the points that were classified as outliers and then returned to the model are in exactly the same places. The only difference really is the thickness of the parameter bars. So let's look at the model displays here. And again, if you compare these two displays, everything is identical. So the wizard has done exactly the same thing with the collapse data as with the original even data, because the data is the same. All of these parameters are the same. The display just looks a little bit different because of the different scale here. Now if I run a forecast for each of these, let's do a default forecast. And you can see in the case of the collapse data, we have the accident years here. We have 423, 2173, 1483. These are the model values for those cells. Those same values appear here, but for each first quarter of each year. So they appear here separated by well, 6 lines, no, 7 lines in the display, but in fact they're just consecutive years. So you can see the numbers here are the same. If I look at the forecast summaries, tile those next to each other, again we see the numbers are exactly the same, but they are ordered differently here. The accident quarters are in place, and the accident quarters with the 0 data receive 0 forecasts. Mind you, the 0 forecasts here only occurred because the exposures were 0. In this case, it may be of interest to see what would happen if I was to redo this model. Let me go back to the even data set here. I'm going to create a new PLI, and I'm going to have no exposure associated with this one. There it is. So this PLI now has no exposure, so the forecast ends up exactly the same. I'm now going to run the wizard on this one. Sorry, the SGI parameters stay exactly the same. If I run the wizard on this one, it should also come out to be the same. However, the forecast will be different. So let me just run the wizard here. Okay, we're just coming back as the wizard completes its job. And what I want to do is I'm going to close down the collapsed. And now I'm just going to look at the two model displays here side by side. And again, the model displays are identical, the parameters are identical. Now if I run forecasts on these, default forecasts, you can see that in, let me place the two forecast tables side by side. In the case where I had no exposure, the forecasting actually forecast for those accident periods that had no data, because it didn't distinguish them from the others. So you have values in all of these and you end up with a vastly different result. In fact, the difference here is about 4 times the value here, because the 3 accident periods that should be given 0 forecasts are actually given their full weight in this one, which doesn't have the exposure created in order to zero out the forecasts on those 0 periods. So that was one of the workarounds that needed to be done when we didn't have uneven periods in PTF, but it's instructive to see how that works now. And of course, all of what you see here would also be in play in a situation where you were truncating, where you were collapsing data sets which did in fact have data in all the periods, but you were collapsing for reasons of gaining a forecast that matches your accounting methods more precisely. Okay, well that's the end of that demonstration. Thank you.